speak from over here.
Hi, everybody. Can everyone hear me okay? Okay. So what we're going to be talking about today is the September-October topic. We're just going to be going over a couple of key terms first and make sure that everybody's on the same page before we go into positions that you can run or basic things that you can understand in the context of the topic. So the wording of the resolution, if you haven't gotten it already, is resolved. Countries ought to prohibit. Oh, yeah. Resolved, countries ought to prohibit the production of nuclear power. So I'll give you some seconds to write that down. Okay. So starting with the key terms, the first thing, of course, would be country. The resolution talks about countries, so obviously you're probably going to have to focus on more than one. It's defined as a nation with its own government occupying a particular territory. Next, I'm sure many of you are familiar with the concept of ought, but basically you're going to be debating about what's right or wrong in the context of the topic, seeing which side of the resolution is either true or has the best comparative worlds, etc. The next thing is prohibit, which is a central part of the resolution. Please keep in mind that it's actually forbidding something by law. So even if someone talks about, for example, restrictions or getting rid or reducing the amount of power that's produced, you probably want to keep in mind that the resolution basically calls for us to engage in a debate about a ban of these nuclear powers, not just a restriction or reduction of it. Next, the definition of production is the action of making or manufacturing from components of raw materials or the process of being so manufactured. So basically just making things. And finally, we have nuclear power, which is the thesis of the resolution, and it's electric or motive power generated by a nuclear reactor. And we will talk about that more. Also, in smaller texts, we wanted to include the second definition that's on Google, which is a country that has nuclear weapons. The reason that we incorporated that is because we know there's probably going to be people who run AFs in the context of that. We are going to say that's probably not the direction that the topic wanted, i.e. it's talking specifically about energy that's being produced, but we wanted you to recognize that that definition is there, so that's why we included it.
So, this raises briefly a couple questions about what is nuclear power. Can everyone hear me? Yes? Okay, cool. So the first thing to recognize here is that nuclear power, we're probably talking about the mechanical operations that actually produce electricity. And the production of nuclear power probably deals with that, as opposed to, for instance, research and development. So there's lots of research currently done on things like nuclear fusion, which is not actually producing nuclear power in any sort of functional way for governments. It's not clear that the affirmative would have to stop that form of research or other types of research related to nuclear energy, even if they stop the production of nuclear power in the context of a country's electricity and power production schemas. Now, hopefully, since you guys have had this topic since this morning, you have a general idea of how nuclear energy works. We want to briefly talk about some of the mechanics here. The first one is the distinction between what's known as fission and fusion, or nuclear fission and nuclear fusion. And the easiest way to understand this distinction is just the distinction between breaking things apart versus fusing things together. So nuclear fission operates by you have certain heavy isotopes of various atoms and elements, like uranium. And certain uranium isotopes are such that they are what's called unstable, which means that if their nucleus is hit in certain ways, it'll burst apart. This then creates what's known as a chain reaction in a nuclear fission situation. So you have a heavy isotopic nucleus of an atom, which is the center part composed of protons and neutrons. You then have a neutron that goes and hits it, okay? And once it hits it, it bursts apart. And then these individual things hit other neutrons, other nucleuses, which burst them apart, which hit other nucleuses, which burst them apart, which creates a chain reaction. Now, the way nuclear energy works is it involves taking these atoms, right, and breaking them into different types of elements. And these different types of elements are going to end up having less total density than the initial element, and the remaining density gets turned into energy. Okay? Because we all know via Einstein's E equals mc squared, the energy turns out to be equatable to matter. And so we take the extra matter that was otherwise in these isotopes, and when we create these new elements without the same total mass, the remaining mass gets turned into energy in a very, very efficient fashion. This chain reaction is what's known as nuclear fission. The other type of nuclear energy that's talked about is nuclear fusion. And nuclear fusion is what we do to get much more powerful reactions. For instance, our most powerful nuclear weapons are nuclear fusion weapons. And what happens here is rather than splitting apart certain atoms, we're actually fusing them together. This is what, for instance, happens in the inside of the sun. And so what happens is you have very densely and very fast-moving hydrogen atoms, and these hydrogen atoms hit one another so quickly they kind of fuse together and create new, heavier elements, and in the process, it produces a lot of extra energy. Currently, we do this for nuclear weapons by basically having fission reactions on the outside of a core, which makes it go so fast and pushes it together so much that it fuses the core to create a fusion reaction. And the idea behind nuclear fusion for an energy purpose would be to try to do a similar sort of procedure, either by having lasers that shoot electrons and neutrons at each other really quickly, or by creating plasma reactions, etc. The different ways that scientists try to create this to produce energy. But currently this is not economically viable. There are no active nuclear fusion plants that are producing energy for a town or anything like that. The science just isn't there yet. And there's a question about how soon the energy is going to get there, which might be relevant to some of the questions about just how good nuclear energy and nuclear power turns out to be. There are different types of fissile materials. The primary one used in contemporary nuclear power plants is uranium. And this uranium then gets used and it tends to degrade into other things like iodine and other forms of uranium and plutonium, some of which can also be used in nuclear reactors, but it's very uncommon. For instance, plutonium, this one, is often used in bombs, but it is not frequently used to create energy. There are other ones, such as thorium, which some people talk about as being the best system to do, but we don't currently have any substantial economically viable thorium reactors. So while people will talk about these as being a better alternative if we can get the science there, it's currently not produced in this sort of way. The enrichment process, So when we have these nuclear fission reactions, which is what we're talking about in the current system, the way it works is we take a critical mass of uranium. And a critical mass is just the amount which is going to start this chain reaction. And in order to get it, we have to have the uranium be pure enough uranium that we can pump enough uranium close together to create this critical mass. So the analogy here is to imagine oatmeal raisin cookies. If you have a bunch of oatmeal raisin cookies and you don't want the cookie part, you just want all the raisins to be close together, because you think that'll somehow turn it back into a grape, you're going to have a problem, Because you just mash all the oatmeal raisin cookies together, you're going to have too much oatmeal in between the raisins, So you're not going to be able to try to reproduce a grape by combining all the raisins. It turns out you can't create a grape even once you get rid of all the oatmeal, which is a shame, but so it goes. So what you'd have to do if you were trying this, like some of you probably have, you would first have to remove all the oatmeal in some fashion, This is really hard to do with little bits of uranium, though. So what we do is we put it in centrifuges, which are just things that spin stuff really, really fast, And because it spins it really, really fast, the heavier parts of it will get pushed, and so it creates layers, of the different elements based on the heavier elements on the furthest out and the lightest elements on the inside, Once you spun it fast enough, And then you can take the layer of uranium, and you have pure uranium, which you can combine in order to create a critical mass that creates a nuclear reaction. Now, the enrichment process for nuclear power does not require nearly as pure uranium as you need for a nuclear weapon. And the reason for this is a nuclear weapon requires you to have a critical mass that goes all at once and basically burns through it all almost instantaneously, because that gets the massive output of energy right away, which is what we want in a weapon. But you don't want that for nuclear power. You want a slower burn, which will last a while, which produces consistent heat. And so for that, you need a far less pure form of uranium. This becomes relevant, for instance, when we talk about the situation in Iran, Because in Iran, they are centrifuges, which they maintain are only useful for producing uranium helpful for nuclear power, but not nuclear weapons. And the claim there is that they are not powerful enough centrifuges to get the uranium pure enough for the purposes of weaponized situations.
It might be helpful at this point to explain, I don't think they can read it, that picture on the far right. What's going on there is the very top picture, that circle that's almost entirely purple with a tiny sliver of red, is an example of what naturally occurring uranium in the environment looks like. The purple is uranium-238, or am I getting these backwards? Yes, uranium-238, and the little red sliver is the amount of uranium-235, which basically is just a very similar version of uranium that has slightly fewer neutrons in its nucleus, and that's the type that you need. Then the second picture, the one that's still almost entirely purple but with a slightly wider red sliver, that's the example of the type of uranium you use in a nuclear power plant, where we just need a little bit more of the uranium-235 to make the reaction work. And so you refine it until you get that much. And the bottom one is what you'd have in an average nuclear weapon using uranium. You would need it to be almost entirely uranium-235. And so there's a massive jump in terms of the refinedness of the uranium between nuclear power and nuclear weapons. So they're not exactly the same thing, even though they use the same principles.
Yeah. The coolant is an interesting question. So there's the way a nuclear reaction, oh yeah, question?
Yeah, this might be a really dumb question, but nuclear fission and nuclear fusion can only occur like in science labs. Like it can't occur like naturally in the environment.
Well, so you have, no. So nuclear fission is always happening a little bit all over the place, right? So if I just have like a rock of uranium, it is slowly turning into a different type of uranium, right?
Okay, just not as like rapidly as it would.
Right, but a chain reaction can only be produced, but it can still happen naturally, right? The sun is a natural instance of nuclear fusion, right? And I think like there's some stuff that goes on like the Earth's core, right, which has like fission-esque things that keep like I don't remember. Yeah.
So currently is fission being used at all?
What?
Currently is fusion being used at all?
Well, we have like labs trying to do fusion, and we can like produce fusion reactions, but we cannot get any economically viable form of energy coming from it.
Also weapons.
Yeah, we use it for weapons. Yeah, all the best weapons are fusion. The best is the most destructive. I don't think those are actually good weapons. Any other questions about that?
And also, yeah, feel free to raise your hands if you have a question, and we also take questions at the end.
Yeah.
Is there a correlation between being fission and fusion and being U-235 and U-238?
Yeah, so you don't use uranium for most fusion reactions. You only use uranium for fission reactions, because fission reactions take really heavy elements like uranium and make them into lighter, and like change those. While fusion, you generally take really light elements like hydrogen and combine them, okay? So fission will generally use uranium, while fusion will generally use things like hydrogen. Yeah.
So in the bottom picture, they're showing the amount of U-35 needed for a fission bomb?
Yes,
Yes.
U-235.
So there are fission bombs, fission weapons.
Yes, so these were like what we dropped on Japan during World War II. Those were fission bombs. And the first one, the one in Hiroshima, was this sort, with uranium-based. The one in Nagasaki was a plutonium-based weapon, which we'll talk about when we talk about the terrorism impact stories. Yeah. Fusion weapon we've used? Well, the U.S. has only used strategic nuclear weapons twice in its history, both on Japan during World War II, and nuclear fusion was not a viable technology then. But we have like tested fusion nuclear weapons back before we stopped testing nuclear weapons.
Have you heard the term H-bomb or hydrogen bomb? Think fusion weapon.
Yeah. While an atomic bomb is generally considered a fission bomb. All right, so once we then have this enriched uranium, right, we can't just turn heat into energy, right? It doesn't work that way. So what we do is we put it in a tank, basically, and surround it with water, okay? The water gets heated up by the high amount of heat produced, which then turns into steam, either directly or we pump it somewhere else to turn into steam, right, under pressurized systems. And that steam will then turn a turbine. Does this make sense to everyone? And turning the turbine is then what produces the electricity. So that's how we get from the nuclear reaction to the electricity. And there's different things used for this coolant, right? So the ones we commonly use is just water, or sometimes heavy water, which is water with like extra weird hydrogen neutrons in it. I don't really get the distinction that well. You don't drink heavy water. That's important. But it just affects like how much heat it can produce and how the energy transfer works. And so we then take these coolants. The other like coolants don't really use this, right? But people like talk about. What'd you say it was called?
So molten salt is an example. You use a molten salt which is a little bit more expensive in terms of producing it, because obviously you can't just like pull it out of a lake or an ocean or something like that. And it also requires slightly higher level of grade of uranium, so it's a little bit more worrisome in terms of getting closer to nuclear weapons potential. But it has the advantage of being a lot more safe in terms of the process, just because the way that molten salt works as a coolant means that if anything ever start to go awry and get much hotter than we want to, it naturally has a built-in method of cooling itself back down. Because when the molten salt gets too hot, it can do things like end up melting a cap that allows everything to drain out naturally. And so it's a lot safer in terms of accidents to use molten salt reactors.
Yep. The last thing to talk about in terms of what is going on with nuclear power is the question of reprocessing, which you'll see a lot in the literature. The reprocessing question deals with the first stage of nuclear waste. So after we use our nuclear energy, we take like this, okay, and then we use it up and it degrades, not exactly, but closer to something like this again, okay, with some extra chemicals in there, some extra elements in there, like plutonium and iodine. And then if we want, we can put it back in a chemical process or back into a centrifuge and reprocess it to make it into usable material again. And so one of the strategies used is what's known as reprocessing. So we take our waste and we reprocess it to make it usable again. And then the end result is that we get a much shorter lifetime chemicals with lots more like plutonium, which degrade naturally in only like 12,000 years, as opposed to like 2.5 million years, right? So that we'll talk about when we talk about like different advantage scenarios, because there are arguments in favor of and against reprocessing as a way to decrease waste and decrease the long-term harmful effects of waste. Any questions about like the general idea of what's going on with nuclear power? Yeah.
Yeah, how long does it take for the waste to actually turn into anything that you can either use or get rid of?
Well, what do you mean by get rid of?
Like in a safe way that doesn't present a risk to human health.
Oh.
So like, for example, not storing it inside of the mountain on the
Yeah, so the way nuclear waste works is it has what's called a half-life.
Yes.
And the half-life is the amount of time it takes to degrade to the point of it only has half of the same amount of radioactive material. So let's say I started with 10 pounds of radioactive material with a half-life of 2.5 million years. That means after 2.5 million years, I'll have 5 pounds left. And after another 2.5 million years, I'll have 2.5 pounds left. And after another 2.5 million years, I'll have 1.25 pounds left. Does that make sense to everyone? Right? So the half-life is the amount of time it takes for half of it to degrade. Now, this process is really going to depend on how much waste you start out with, right? Because you start out with 20, right, let's say, pounds of waste, and that's unsafe, versus 40 pounds, it'll take a lot longer just, right, depending on how much you have before it will be safe, right? But the half-life is often what we talk about in terms of assessing the long-term effects. Because an equal amount of plutonium versus an equal amount of uranium will take like millions of years before it's safe to process, while plutonium probably takes between 10 to 50,000 years. I don't know.
So thorium's one of the more speculative ones, and so people discuss thorium reactors, and a lot of the advocates, say it's, if developed, would be one of the most successful in terms of abundance of the element, energy production, and so on. And I believe it's one of the cleaner ones as well. The big problem with thorium is just we don't actually have that technology yet. It's one of those cool things we would like to be able to do in the future, like economically viable fusion reactors, but it's not something that's currently existing in any nuclear power plant.
There's another question back there.
Oh yeah. As the amount of mass in like the sample decreases, does efficiency also decrease?
Efficiency?
Yeah.
In terms of energy production?
Yeah.
Well, so, I mean, there'll be sort of major points. For instance, when it goes from like the critical mass, which creates a chain reaction, to just like normal decay, right? And that sort of decrease is going to make a big difference. This is what happens with like when you go from a nuclear bomb being a bomb to a nuclear bomb just being like a generally unsafe place to live because there's lots of radiation, right? And that's that sort of transition. But once you're at that point, it's just going to, the less radiation, the less radioactive material there is, the less radiation produced. The big gap, though, is between the critical mass and the non-critical mass. And that's where like the energy production really changes qualitatively. Yeah?
If it's the steam that like makes the energy, that makes the turbine turn into electricity, why can't I just like stick a hot rock in water and have steam?
You can, but the hot rock will cool down really fast.
It's not efficient.
Yeah.
Yeah.
Right, you just like don't have hot enough rocks. Well, actually, I mean, that's one way to think about uranium. It's just a really, really, really hot rock that just keeps getting hotter. Right.
It doesn't get cooled up.
Yeah, because the question is, how do you get that rock hot? My guess is your natural process would probably involve heating it up somehow, and you don't have a net efficient method of getting energy, because you're wasting energy heating it up, and then that's heating up steam, which gets you energy, but then you have to spend the energy heating up the rock. So if there are millions and millions of really hot rocks in the environment, you'd be fine. But the question is, where would those be, and how would we have an entire global economy run on hot rocks cooling down?
Is it theoretically possible to build like a turbine over a volcano? Theoretically.
Yes, it is. That's geothermal energy. People have practical solutions for that even at the consumer scale.
Yeah, it's probably not like the.
Building a turbine?
Yeah, you wouldn't really use the danger with a volcano is volcanoes tend to be very geologically active, right? What you generally want is a place with like a hot spring
Yeah.
or something like that, right? And hot springs, though, like natural hot springs are a very good place to develop geothermal energy.
And even barring the whole like they can erupt thing, the caldera of the volcano is not where most of the energy is. You'd want something like right under the ground, right by the consistent flow of magma. Because oftentimes you see like volcanoes that aren't active, they get crusted over the top because they're exposed to the air, which wouldn't be true of underground geothermal energy.
Any other question about nuclear power before we go on? All right, cool.
Okay, so kind of moving away from the exactly how they're produced, we also have to recognize that a large majority of the world, or a significant amount of countries, are starting to use nuclear energy in order to sustain themselves. So as of May 2016, 30 countries worldwide were operating 444 nuclear reactors, which is a pretty big amount. Of course, it can definitely expand, and that's what the debate is going to be about. But in the status quo, we have to recognize that that's something that a lot of people are already doing. Additionally, nuclear power plants provided 10.9% of the world's electricity production. So when you're having these debates, something you need to really be thinking about is, what are we going to do in order to replace that 10.9%? That's going to be the job of perhaps the affirmative to do in order to leverage against certain arguments on the negative, but likewise, it's the job of the negative to really show how 10.9% is already significant, and it's only going to get higher, and it's a much better way for us to spend a lot of time on energy development. Additionally, not only does it take up like 10.9% of the energy in the world, but 13 countries rely on at least a quarter of their total electricity being nuclear powered. A primary example is France. Right now, France has 76% of its energy produced by nuclear power, and there is a long list. I'm sure you can find statistics about how much different countries use it, France being the primary example, but there are a lot of really established countries that use it. So France, Belgium, South Korea, and many others. So that's something that you really need to take into account. Also, just in terms of a visual, you can kind of look at the scale at the bottom, and it shows you how much a country is using nuclear power. Right now, of course, there are countries that are more on the lighter part of the spectrum, so maybe 0 to 10% of them are using some form of nuclear energy. However, you can see a lot of like Western countries or a lot of countries in Europe, or particularly Canada and the United States, do participate in at least 25% of their energy, or somewhere around that number of their energy being used. So not only are you thinking about it in terms of countries like France, but what does it mean for us to completely ban nuclear energy in the context of all of these countries at once? What is it going to look like? What type of economic impacts are we going to have? What type of international relationship impacts are we going to have? And that's something that you really need to think about. So basic harms. Yeah. What stays on this slide?
So the first of the sort of straightforward arguments in the literature we want to talk about is the threat of accidents, okay? And one of the major arguments against the use of nuclear weapons is just that not necessarily they're more accident prone than other forms of energy, they're not, right? Like, you're much more likely to have some sort of major accident happen at a coal burning plant, but instead that when something goes wrong, the impacts will be far, far worse, right? The risks of some sort of nuclear incident can have far more long-term effects, right, range into like millions of years in the worst-case scenarios before the place can be safe to habit again, right? And also much more severe effects, right? So while coal might produce pollution, which could give someone lung cancer, it's unlikely to give them cancer within days, right? Which could happen in instances of nuclear meltdown with enough radiation being produced. And so there's a major concern that there's a sort of accidents, right, that run the risk when you have nuclear energy. And to give you some sort of idea here, right, there are estimates that we do when we create nuclear plants about how likely accidents are to happen, right? And generally the estimates are things like, right, the probability has to be less than one accident every 10,000 life years, right, of a plant. And while it doesn't seem like a big deal, it does mean that over 100 plants over 100 years, right, you are likely to have at least one accident, right? It also would mean that, like, with our 400 plants currently existing, it means that it is reasonable, even meeting our current standards for how likely accidents have to be, to have one about once every 25 years somewhere in the world, right? And so there are concerns about the safety of nuclear power vis-a-vis other sorts of threats, and in particular the way this poses what's known as a negative externality, right, on other people. The idea of an externality is a fancy word that economists use, and the basic idea is just sometimes when I produce something to get some benefit, it results in harm happening to other people who aren't getting the same benefit. So for instance, if I drive my car, that's going to create pollution. And this pollution is going to make other people's lives slightly worse, right? But they don't get any benefit from me driving their car. So it's just a negative externality. And I don't pay them, right, to undergo the pollution, etc., right? And so lots of things we do have these negative externalities on other people. And the idea here is that, right, the imposition of these risks might be morally problematic. This is especially given how we tend to choose where we put our nuclear reactors, right? We do not put them in wealthy districts, right? We put our nuclear reactors in places largely filled with individuals who have far less political power and suffer from a far greater degree of marginalization. And so there's a concern about putting these accident negative externalities onto populations that have already been significantly marginalized in a political context.
The next threat is relating to waste, and there's a number of these. So the most direct one is, and I think Fred brought this up earlier, is it's going to stay radioactive for a very long time, potentially a very, very, very long time, determining the process that we use. And one thing that's very difficult to do is to store that, because you can't just store it in a box that lasts 100 years. The container or the place you need to store it needs to be secure for thousands or even tens of thousands of years if you want to make sure it doesn't eventually leak out and harm future generations. And so you need to think of extremely long-term storage. And much like the accident problem, if there's a 1 in 10,000 chance per year that this place that you're storing the material gets damaged and leaks, or degrades 1% every 10, 20 years, then eventually you're going to have a problem on your hands, well within the time span that the material will still be radioactive. And so there's potential very, very long-term harms. And this brings up ethical questions related to, say, future generations. Do we have obligations to them? Exactly of what sort? And extremely long-term impacts of waste are things that would be highly relevant to that. More directly, there's environmental impacts in terms of the harm to the aquatic ecosystems around nuclear power plants. Most of the power plants are cooled using water or heavy water, and they actually use a whole lot of water, especially the older versions, because they're less efficient. And so you'll have a nuclear power plant right next to a big lake or a river, and it pulls huge amounts of water out of the river, heats it up a lot, and shoots it back into the river. And that has huge impacts on the ecosystem of that river. So you'll have, say, fish getting killed by the massive loss of water, reintroduction of heated water. You'll have baby fish, or the fish's eggs get killed, which is even one of the larger impacts. And that impacts the global fish population actually relatively largely. So for example, in New York alone, the numbers are something around 17 billion fish getting killed by nuclear power. New Jersey is about 9 billion, that sort of thing. So you're talking about huge amounts of fish lost. And then the last threat that can be related to this is nuclear terrorism. And so the concerns here are, what if terrorists got their hands on uranium and enriched it? Or even more pressingly, one of the byproducts of the natural fission process is plutonium. And as we mentioned earlier, plutonium is more often used in weapons. So suppose they get their hands on plutonium, they could easily create a nuclear bomb. And even if they couldn't get their hands on that, imagine they just have depleted uranium. So even the other forms of uranium that are left over, you could create a radiological weapon where you just set off a bomb with a bunch of nuclear material around it. It doesn't have the nuclear explosion that kills hundreds of thousands of people, but it has the effect of scattering radioactive debris into the air, which also has huge negative effects. And so there's a number of ways that, if not carefully guarded, the nuclear material or the nuclear output could be used by third parties, like terrorists, and that would be a major concern. This is also one of the major concerns that shows up in reprocessing, because it drastically increases the amount and the vulnerability of those sorts of threats. Is that a hand up?
That type of bomb that depleted uranium you were talking about, is that what's called a dirty bomb?
Mm-hmm. Any other questions? All right.
Yeah, so the final basic harm that we have is high energy cost compared to plausible alternatives. So not only are you supposed to be thinking of cost in terms of money, but we also think of cost in terms of the other harms outlined. So not only does it cost more in terms of the short term, because it takes a lot in order for you to either be able to mine this uranium, build the power plants, etc., but it also can contribute to a lot of those a lot of the harms in terms of accidents, waste, etc. If that's the case, a lot of the literature that you might find is going to be either pitting the two things against each other, so nuclear power versus other forms of renewable energy, and that's going to be a place where a lot of debates are going to happen, especially if you're focusing primarily on questions about the environment, or you're focusing a lot in terms of what are the actual implications if you decide to go on a more policy route. So a couple of alternatives that people talk about would be a mix of solar thermal power plants and solar electricity stations. There's also wind farms. Some people talked about windmills, things like that. Those are ways in which people try to show that not only are there better alternatives that are actually possible and can achieve the same benefits, but they are also quicker in going towards a more greener environment. And there's also significant amount of literature in terms of nuclear power kind of being a crutch in terms of us moving towards a more green planet. So what we're doing in the short term, now that becomes a debate for you to have in terms of whether that crutch is something that's justified, something that's good, but we also have to recognize that there are a lot of costs in terms of lives, but also money, especially when there are other alternatives involved.
So this leads us to a discussion of some of the benefits, which are going to act as your primary negative arguments you have on the topic. And the first one deals with global warming. This is probably going to be the most common negative argument on the topic, right? Because one of the real concerns is that nuclear energy might be one of our best short-term solutions to the impending global warming crisis. Even if nuclear energy is not the best long-term energy solution, right? It does seem as though it's one of the better transitionary energy sources to get us away from fossil fuels as quickly as possible, especially coal. And if this is the case, then it may be that a substantial ramp up of our nuclear power is going to be necessary to get us away from current dependence on coal quick enough to stop the impending concerns for global warming, right? So you're going to really clearly want an argument that says, we are currently facing the time period to determine the future of global warming, right? Like there are studies out there that are published very recently that are like, we have 10 years to figure out this global warming situation and to stop using fossil fuels, right? And it does not seem as though much of our other technology, for instance, solar technology or wind technology, can be ramped up fast enough in order to avoid these sort of concerns. But it does seem to be the claim that there is a greater capacity for us to do so with regards to nuclear power. There's also arguments that would indicate that a lot of the countries that are sort of the forerunners in providing this sort of power, such as France, might have a lot of difficulty if we suddenly stopped using nuclear power and finding transitionary technologies, right, which might create undue pressure on the industries, right, such they are not able to cope with increasing demand, et cetera. So there are arguments about how that 10.9% would be filled in with coal, and that coal is going to be enough that means we really cannot and will not be able to solve the global warming crisis.
Relatedly, another concern is think of the other issues beyond global warming that are related to the current use of fossil fuels. One being oil dependence. If all of our energy comes from oil, then you have an issue where we need a lot of oil, more than we currently produce. And you have problems like being dependent on other countries for importing oil. And that can cause, it could cause benefits, but but often it causes harms where, say, we're more constrained to other countries. Like, say, maybe your argument is we have to import more from Saudi Arabia, which forces us to turn a blind eye to negative human rights practices because we need them for our oil, that sort of thing. So there's a number of impacts that you could generate from oil dependence. Relatedly, there's a lot of environmental harms from the other sources of energy that we use. So fracking from natural gas, been in the news a lot lately. Problems like polluting water supplies, causing earthquakes, that sort of thing. Kills and poisons whole lots of people. Another concern, things like air pollution from coal-fired power plants. That's another source of electricity that's major in the United States. We burn a lot of coal to produce our electric energy. If we had more nuclear power, we might have less air pollution because we have less coal. So in addition to the fewer carbon emissions, we also have fewer people dying from more unhealthy air, and other arguments to that effect. And you can think of a lot of reasons based on exactly what we're talking about: natural gas, coal, oil, that would have a number of environmental impacts, like oil spills. So oil spills is an example that maybe there'd be a few less of them if we had a little bit less coal, a little less oil, and a little bit more nuclear power. But this is the general theme of a lot of the negative arguments is we need nuclear energy because it stops us from using all these other impacts, or all these other sources of energy, which have worse impacts and are less sustainable. So these are all concerns that are kind of closely knit together that you can generate a number of impacts off of if you win that nuclear energy majorly displaces oil, coal, natural gas, and so on.
Yeah, and the final two are kind of going hand in hand in terms of general sustainability and development transition technology. So in terms of general sustainability, what you have to recognize is that not only are a lot of countries or recently relying on this form of energy, but it also becomes a question of whether it's something that can meet the needs of a present generation without compromising the needs of future generations. What you need to be doing if you are defending nuclear power is make arguments about how current technology is doing a lot better job at containing these things. We learned from the accidents that we're having. We are able to prevent really harmful things happening to future generations. And not only that, but there is a significant halt in terms of the production of greenhouse gases or things that are really detrimental to the environment. So in the short term, as Marshall said, we are doing something that is really good and also allowing for people to meet their adequate forms of living. The same goes in terms of development transition technology. If individuals are able to not only sustain themselves in the everyday to-day life, it allows for us to make strides towards having a more green environment. If we have something in the short term that allows for us to do so, there's no reason why we shouldn't be allowed to, especially if there's not a significant compromising of people's well-being in the future.
So the next question might be, in terms of specific arguments, say on the affirmative side, in terms of maybe talking about a narrower section of the resolution. And there's a number of ways this might come up. So we discussed a moment ago different ways that the nuclear power could be generated. And so there's a lot of room for discussing different types of specific nuclear power. And maybe it's the affirmative argument that specific forms of nuclear power are uniquely bad. So reprocessing, we mentioned, has specific disadvantages if you want to argue that reprocessing specifically is a bad aspect of nuclear power production. Or different forms of nuclear power, like uranium, plutonium, thorium, et cetera, have different advantages and disadvantages. There's a number of, all those different distinctions are areas where the harms and benefits don't exactly coincide. And so discussing different ones has different strategic advantages, both for the affirmative and for the negative. Likewise, you have different countries, and even different countries combined with the different types of nuclear power production, that generate a number of different specific advantage areas. So maybe the most common default would be the United States, just tends to be like the majority of the English literature on the question. We're also a major nuclear power producer. Alternatively, there's other arguments. For example, China is, if you notice the map, not currently a major producer of nuclear power, but they're one of those countries that account for a large number of the upcoming nuclear power plants because they're trying to wean themselves off of coal. Japan, likewise, has a kind of a unique situation with its nuclear power because it is a nuclear energy producer, but not a nuclear weapons state. And one of the big concerns of Japan is we know they have this massive nuclear industry, and so they could easily get a nuclear bomb if they wanted to within a matter of months because they have the technology already ready. And so maybe an argument would be Japan, in terms of easing Northeast Asian tensions, might have reason to give up its nuclear energy because it reduces its capacity to immediately proliferate were it to want to. That sort of thing. Also, additionally, Iran, I think you'll probably see, will come up from some people who recognize that maybe the easiest state to win offense for getting rid of nuclear power would be Iran, given the current Iran deal and the risks of proliferation. people might try to argue any of these because the specificities of these give the app some unique advantages, especially when the more broad topic puts the app in a pretty, not necessarily hard to defend position, but one that can be easily attacked from a large number of angles, because any negative attack challenging complete prohibition of nuclear power from any side would seem to negate the topic as written. But the question is, are these readings of the resolution, quite as accurate? And I think it's probably an uphill battle in terms of winning that the resolution can be read more permissively to allow the affirmative to talk about, just a specific type or just a specific country. It says countries in general, and it says prohibit, which sounds like a pretty categorical word regarding nuclear power. And since the affirmative, I think, utilizing any of these arguments requires, evaluating the trade-off of, am I willing to defend the much harder to claim interpretation of the resolution as being narrow, or at least allowing narrow claims, in order to garner the more specific offense that might help you in winning the substantive level of the debate. And so that's something to consider. These arguments are probably the less natural, less intuitive readings of the resolution, and so you'll have a harder time winning that you are correct in your reading of the resolution. But if you win it, you give yourself an easy out. And so that's the trade-off there.
Okay, so there's a fairly large amount of critical ground on this topic if you're affirmative. I'm just going to go through a couple of examples that I was able to think of, but don't feel limited to running any of these positions here. I definitely want to push you to look it up if you're interested in running critical positions. The first example is that there's a lot of literature on how nuclear power, particularly nuclear power plants, compromise the lives of racial minorities. So the first example that I have is an article by Michelle Chen, and she talks about radioactive racism, which is something that was kind of found on a bunch of different articles. Basically, the argument there is that there is a lot of targeting, or even if it's not intentional, a lot of setbacks or collateral damage in these communities, because not only are these power plants built in areas where there is a significant urban population, but if they release a lot of this waste, they often end up in these communities. It leaves people sick, it leaves people in a really negative environment, both psychologically, physically, economically, all of those things. If you're also interested in that particular article, it talks about the movement for nuclear power in South Africa. So you don't necessarily have to feel like you have to narrow yourself to unique issues in America in the context of black and brown bodies, but there's a lot of literature in terms of how nuclear power plants are affecting people regardless of where they come from. That's probably a route that you should take, since it's not a resolution that's specific to the United States, so you should definitely look into that. Another example that I thought of in the context of race was Afrofuturism. So if you have any questions about any of these particular theories, you can always meet with me or go to different lectures specific about them. But basically what the argument here is, since a lot of it has to do with science, it has a lot to do with nuclear waste, etc., there's also a lot in terms of science fiction that deals with apocalyptic rhetoric or apocalyptic scenarios. What Afrofuturism tries to do is radically imagine some type of future in which these things are not the case, or where black lives are in a much better position. So there is a lot that you can do in terms of either putting fiction in your affirmative, having some type of performative aspect in your affirmative that deals with sci-fi. And yeah, if that's something that you're interested in, you can definitely talk to me. You can also look at the source there. It specifically talks about black speculative fiction and why it's good in terms of talking about these particular issues, etc. And the final example I have in the context of race, although there's a lot of intersections in the other criticisms as well, is in the context of Japan, or attitudes towards Asian communities internally and externally. So the first argument there by Christine Schradner talks about how Fukushima became basically like a Japanese Katrina. And she talks about how there is a lot of internal conflict that happened there in terms of the individuals who were affected disproportionately by the harm that came from the power plants were poor people, black blue-collar workers, they're literally dubbed black blue-collar workers, and children were people who were primarily victims of that. So there is clearly some type of different understanding of what it means to be a minority in a predominantly homogenous community, but there's a significant amount of literature on that. You can look at that source as well as the citations in order for you to learn a little bit more about that. The second example is Charles Perrow, and the title kind of says it all. It's Nuclear Denial from Hiroshima to Fukushima, and it just talks about the ways in which our discussions about nuclear power, nuclear weapons, etc., always try to downplay the harms because we do not believe that these bodies are anything but fungible, and as a result, there's no reason, as a result, we basically just don't pay attention to a lot of these issues. If you're pushing for it on the affirmative, you definitely want to talk about how, yes, this is actually really harmful. It plays into a particular attitude that the West has towards like Asian communities, particularly the way that it interacted with Japan in the past. And yeah, that's something that you can do on the affirmative. The second branch of critical arguments that you can do on the app deals with nuclear colonialism. There's a lot of literature on nuclear colonialism because it's also a term of art. The specific example that I have is in the context of indigenous peoples and what it means for nuclear waste to be dumped at reservations. So because they are not technically, if you live on a native reservation, you're not technically like subject to the same laws in the United States. A lot of Native communities find themselves being victim to a lot of these companies because there's no way for them to be held accountable. So there is a lot of literature on indigenous communities and their reaction to that, how it hurts them, what they want to do in terms of getting rid of those nuclear power plants, etc. Okay, so the next example that I have is anthropocentrism. That should be kind of intuitive based on a lot of the harms that we were talking about before. So that's an example of just understanding anthropocentrism in general. For those of you who don't know what it is, basically is just the idea that we prioritize humans over the environment all the time. So if you're running it on the affirmative, it would be a criticism of anthropocentrism. The argument there is that nuclear power constantly puts the environment at risk. Marshall gave the specific example of, Marshall and Jacob gave the specific example of how fish are an example of nature that constantly gets hurt by this. That's something that you can talk about. You can definitely talk about water in general. You can talk about the environment. You can talk about trees, anything that has to do with the ways in which humans constantly pit the environment or subjugate the environment in a really horrible way. And the next part is nuclear, oh, yeah, it's the same thing. Yeah, so it's erased. But yeah, so those are arguments that you can use in the context of critical responses. That's just something to get started with. Don't worry if you didn't get all of the sites down. We're going to be able to send the PowerPoints if any of you are interested in those things. And yeah.
So we want to talk briefly about some of the more abstract philosophical arguments on the topic. The first one here is going to be a question of the structure of negative externalities and the way that affirming would decrease negative externalities in a way that might be morally questionable. So, for instance, there seem to be lots of negative externalities which cannot in any way be internalized. So there are ways, for instance, to internalize pollution that I might cause when I burn greenhouse gases, right? Which if this pollution causes some health risk, I might be able to pay a certain amount of money to some fund that helps resolve those health harms that pollution causes, something like that. But it does not seem as though it is possible, necessarily, to internalize, right, or to make me pay for the negative consequences of the random harms that occur from nuclear energy. For instance, because it happens so far into the future and can affect future generations so distantly into the future that there is no way for us to internalize the costs that we impose on those future people. All the sort of general arguments about the risks of nuclear weapons would all apply here. For instance, the very high costs that this could have on individual people, right, would all be negative externalities you could cite. The way that lots of people are harmed in the mining of uranium, right, and in the general process of enriching uranium. For instance, there's lots of evidence about the expectation for women not to have children if they work in enriching uranium because of the amount of radiation they're exposed to. Right, there's all sorts of negative externalities. It seems like the process of nuclear production imposes on people, which you could argue it's impossible to internalize, which makes it an unethical form of energy production. Another sort of AF which might work and might just not make any sense at all, I'm not sure. Well, oh well. is a sort of anti-consumerism position, which just says that the large amount of consumerism is what's really the problem, that we should not try to find ways to produce enough energy to satisfy our current style of living, because there's just no way ethically to live at our current levels of energy consumption, right? There just is no such thing as an ethical way to produce energy for the way the West currently utilizes resources. There just is no such thing as an ethical way to produce it, because the very quantity of energy that we utilize is itself something that has to be called into question morally, and itself something that just cannot, so anything that is a sort of part of the system would be morally wrong. In the same way, someone might challenge eating meat, right, on the grounds that participation in this sort of system itself and the overconsumption inputs from the system might just be morally wrong. You might make an argument like this. Now, there's a question of if you get to claim that because this sort of consumerism is bad, that we shouldn't use nuclear energy, because it doesn't seem as though just getting rid of nuclear energy will result in us not being consumeristic. It just seems as though it'll result in massive harm to the environment when we use coal instead. And so you'd have to win a sort of ethical standpoint that says it is wrong, right, to do these things which are part of consumerism, and it's something that we ought not do, even if it's the case that we won't fix the harms by not doing them. So I'm not sure if that's possible or not, but you can try. Yeah.
What philosophical authors would you recommend if you were trying to write a position like that?
So, yeah. So there's a number of things here. I will send out some articles I found on the subject matter. The first thing to look at is there's a search term called alternative hedonism. I don't remember exactly what the author's name is, but it's an applied ethicist who does a lot on how like modern capitalist consumerist cultures just cannot have an ethical form of living, and there is no way to resolve the negative utilitarian impacts implicit in modern forms of consumerism, and that only a sort of rejection of the assumptions of consumerism would allow a sort of ethical standpoint. What?
Do you think universalizability is some sort of a Kantian type framework works into this, or is that like more of seeing consequences of consumption?
Well, so you might be able to make a sort of sustainability argument of a Kantian form. I don't think that would be a question of consumerism. That might be a different sort of standpoint. The sustainability argument, the tricky thing here is it just seems as though nuclear power helps sustainability. Or at least it seems like nuclear power might make things more sustainable, not less. And it's not clear that getting rid of nuclear power is something that is not universal. It's not like the nuclear power is the not universalizable thing. And so it's not clear you get the connection to the deontological violation the way you need for that sort of framework. But maybe. I think there are also just really good philosophy versions of a lot of the affirmative cases that SunHee talked about. So, for instance, there's anthro arguments about like philosophical reasons we have to take account of animal interests, and there are good reasons to think that animals don't benefit at all from our nuclear energy policy, except maybe if it stops global warming, which is an interesting question, right? But they're like definitely harmed by nuclear waste and things of that sort, right? And so there could be an argument about like equal concern for animal interests as it relates to nuclear weapon. There's also arguments about sort of Rawlsian concerns and sort of maxi-min or contractualist concerns with nuclear energy that basically say it is bad to take these sort of general environmental harms, right, that currently are imposed on society as a whole by things like global warming, and then make very specific harms that seriously hurt some people, right, in order to resolve them. That displacement and targeting of certain groups in the way that they are harmed in very severe ways by nuclear energy is morally impermissible, irrespective of the larger sort of consequential or social beneficial effects that nuclear energy might have. And so that might be another option for how you could make, I think, some effective philosophical affirmatives on this topic.
So, next topic of discussion is on the negative, what can you do about the more specific political aspects and implementation-based aspects of nuclear power. And there's a number of things. So, one argument that might bolster the general basic negative arguments we were discussing earlier about, say, solving global warming or reducing environmental impacts is to suggest in the negative not just that we maintain current levels of nuclear power and don't prohibit them, but that we should actively ramp them up and build more nuclear power plants and increase more funding for R&D and things like that. And the argument would go, even if the current levels are not good enough to solve these problems, more is better. And it's probably true in the context of global warming that the current amount of nuclear power, which is only a relatively small fraction of overall energy use globally and in most countries, is not going to be the thing that makes or breaks whether we create runaway global warming. But you could argue that nuclear power has the potential to do that if we were to increase our commitment to it. And so this is an argument that can make the negative claims stronger. It also makes some of the disadvantages of nuclear power stronger, because the more nuclear power we have, the more risk of accidents, the more risk of waste, etc. But it gets you over some of the tricky problems of defending that the status quo allows just the right amount of nuclear power to happen. And it's not something the AF can really refute, because obviously the AF can't say, yeah, I agree that we should produce more nuclear power. They're committed to complete prohibition. And so the negative can choose to increase, if they would like to, claim even larger benefits while potentially linking to larger harms. Conversely, and this is the third bullet point, you might do the opposite. And you might say, yeah, I agree with the affirmative that in general, maybe the status quo amount of nuclear power and the way we do it is not the best way. But there's ways we could decrease it without completely getting rid of it entirely. And so you say, there's still some benefits to nuclear energy. It still has its utility in some purposes. And maybe if there's problems, then we can do things like reduce the total amount we produce, or reduce the types and number of reactors we have, and restrict it in a number of ways to solve the worst harms without banning it. And so this is the flip side of that. You'll have fewer benefits to a much more regulated, much tinier nuclear industry, but you also have much fewer harms. And so maybe the argument here is we just get rid of the worst forms of nuclear power via various restrictions and so on. And it mitigates the affirmative at the cost of potentially mitigating a lot of the negative claims. Another thing you can do, and this is the flip side of that AF argument we were discussing a moment ago, is the negative can use the advantage of the differences between different types and ways of producing nuclear power. And so the negative can say, I agree that these forms of reactors are bad, but we should use these other forms of reactors because they have a different set of costs and benefits that maybe make my opponent's arguments much less strong. So, for example, the different coolants have different level of risk in terms of safety versus proliferation. And you might choose to say, well, my opponent talked about this one particular concern and only focused on safety, so we should use a molten salt reactor which is more safe, even though it links to other arguments that say you recognize your opponent has not presented. And so there's a number of ways to exploit that. Likewise, there's a number of other distinctions. So for example, types of usage. Nuclear submarines. There's been discussion of putting small power plants on nuclear bases to power them. Things like that could be an example of a specific use of nuclear power that's much more limited than producing energy for the entire consumer economic system. Another discussion that was kind of related to that is smaller, more modular forms of nuclear power is another thing that's been proposed. Is instead of having the massive power plants we currently do, you can have much smaller ones that in most ways are a lot safer. They don't have the risk of massive meltdown, often self-contained, more resistant to earthquakes, that sort of thing. They still produce waste, which so they still link to that argument. But they might avoid a lot of the other harms. The cost is they don't produce as much energy. And so they might not be the basis of an entire economy, but they can do specific things, like power a military installation, or other more moderate uses. And so you might say that those are a better example of the way we can move nuclear power into the future, something more focused on smaller nuclear power plants. The last thing to discuss is outside of simply restricting nuclear production or increasing nuclear production, there's other forms of restrictions that might also be useful for the negative in terms of responding to some of the affirmative harms, because there's other ways of resolving them, short of banning out entirely the nuclear power sector. So for example, there's arguments discussed earlier about environmental racism. Most of them don't happen at the production phase of the nuclear industry. It's not the conversion of highly enriched uranium, or not highly enriched, it's low enriched, we discussed that a moment ago. It's not the conversion of enriched uranium to power that causes those harms. It's either in the phase before that, when we're extracting the uranium, or the phase after that, when we're dumping the waste. And so as the negative, you could say, well, the problem you're identifying doesn't require us to ban production of nuclear power. It requires us to change the ways we produce the necessary fissile materials and the ways we dispose of it. And so maybe the solution is to change the sites we use, not put them in such unjust places, change how we get uranium, not extract it with no compensation. And that's the way we solve these nuclear-related harms without actually reducing or cutting into the nuclear industry. Likewise, another argument you might make is if there are arguments about nuclear energy, sorry, I don't know why I didn't think of that, why nuclear energy is bad, because it will lead to things like alternative energies being crowded out. An argument I think was discussed a moment ago. How if we have nuclear energy, we're not going to use alternative energies like wind and solar power to their full extent. Maybe in the negative, you argue, well, there's other ways to motivate people to use alternative energy besides just getting rid of moderate solutions. Maybe we could have nuclear energy, but increase incentives for solar, wind, and things like that. So to not allow nuclear energy to crowd out those better forms of alternative energy. And so these are all relevant considerations. There's a number of them. And I would suggest exploring any of them because they can all be very potentially strategic.
Okay, so arguments on the negative in terms of critical literature, you're probably going to have to spend a little more time trying to find a really good link to the affirmative, because you don't want to just read a generic K on the neg. Were two examples that I was able to attach to the topic. The first one is in the context of feminism, particularly indigenous feminism. So the first source is by Jane Caputi, and it's a really interesting negative article. You're probably going to have to spend some time reading it if you decide you want to take this approach and rereading it again. But her argument there is that nuclear power is something that's sacred. She says that we need to affirm nuclear power as a symbol of the chaotic and emotional and completely reactive feminine stereotype that's imposed on women. So rather than allowing for nuclear power to be seen as a masculine form of dominance, or nuclear power to be seen as something that's phallic, or something that shows male dominance in terms of sexuality, etc., her argument is that we should reclaim that symbol and we should apply metaphors in that context. So kind of just to give you an understanding of that, I'll read a particular quote from that. She says, "Certainly, that metaphor introduces a logic that is completely contrary, even infuriating, to patriarchal logic. Allen's metaphor claims for women's identification with the cosmic forces of the universe and suggests that in order for goddess spirituality to achieve the world transformative power that so many feminists argue is capable of, we must acknowledge the presence of goddesses not only in past myths and familiar images, but also in contemporary, even technological realities." So the argument is that even in indigenous cultures, they use storytelling, they use the past in order for people to identify with particular symbols. The argument here is that we should recognize nuclear power as a new form of that symbol. We should be applying these metaphors to things that are also technologically advanced, or else we allow for this type of identification to die out. So that's a really interesting article. I definitely recommend looking at it. The second example that I had is more of a broader link to an argument about Black nihilism. There are a lot of people on staff that you can talk to about Black nihilism, but I forgot to put the title there, but it's Calvin Warren, and the title is Black Nihilism and the Politics of Hope. The argument that you can kind of go there is based on the quote that I put above. It says, "The Southern Negro may well wonder what fallout can do to him that the local police chief cannot." So it kind of goes with this idea that there's not really anything to lose in that particular scenario. Maybe you can have a negative that talks about how maybe the risks are worth it. Maybe the risks are something that can incentivize some type of particular change. Maybe you want to go for an obsession with humanism argument in terms of the affirmative, trying to stop horrible things from happening in terms of nuclear power, especially since it's in the context of communities of color, particularly Black communities. There's a lot that you can do in terms of that particular literature. I would say if you decide to go that route, just make sure that the link is very specific to the affirmative that you are going against, and you should be fine on the negative.
Lastly, I want to conclude by talking about a couple of more philosophical and abstract negative positions. These are a little tricky on this topic. One which I don't really like, but is going to be run, so you should be prepared for it, is a strong form of libertarianism negative position. There are some libertarians who explicitly say that the government should let people, if they want to, make nuclear reactors in their backyard, if that's what they want to do, and that sort of anarcho-capitalism will solve for the risks involved. This requires a very, very strong form of libertarianism, especially given that most apps, I think, are going to have really strong arguments about the negative externalities associated with nuclear energy. There are good reasons to think that even libertarians think the government can regulate practices that impose strong externalities. So you have to have a very strong form of the government should not interfere with what people do. People have a moral right to create nuclear power if they want, and that the government has no right to stop them because it's a violation of human freedom. I don't really recommend this argument, but people are going to run it, so you should be ready for it, just because there's some literature about it by people who seem to really like the freedom to build their own nuclear weapons and power. The next argument, which I think is a little more plausible, would focus on the need for developmental technologies. And there's some literature that talks about taking Martha Nussbaum, who's, I think, a really top-notch philosopher, who argues for what's called the capabilities approach for international development. And you can do some more research on this. The essential idea is just that we need to look at the way that certain international structures and rules and policies create or decrease individual capabilities and capacities for flourishing, and that one of the things that nuclear energy is going to be really useful for is a transitionary technology that allows societies in which there's a significant constriction of individual capacity, right? For instance, places where you do not have many options for females to get educated, right? Because there just aren't school systems that enable it. There are arguments that say like the developmental process would be significantly improved via the utilization of nuclear energy. And nuclear energy is a very, very effective way for some specific countries to develop in a way that would increase capabilities and human capabilities within those nations. The other app that there seems to be some literature for, or the other neg that takes a more abstract philosophical position, is one grounded in sort of a social pragmatism. And the argument here is that the AF, by banning consistently all nuclear power, takes the wrong approach. And there's literature that talks about the need for sort of experimental take an experimental approach to nuclear energy in order to account for the fact that no one-size policy is ever going to be able to deal with the complexities of energy. And that energy has to be responsive to individual need. And the way that technology constantly changes means that a super generalized approach to things like energy is just a really bad way to do it. And there's some specific stuff about how we should not take like a super broad approach to nuclear power either, that we need an experimental approach to power, where we recognize that there are huge amounts of risk, so we do things very slowly and carefully, but it's important to keep options open, to keep trying out different forms of nuclear technology, etc., in order to be able to find solutions that will work long-term, rather than imposing monolithically one view about what sort of approach is correct and what sort is not. And this would challenge the sort of strength of the AF and say the AF is too strong as an approach to nuclear power. We need to have a far more flexible and pragmatic approach to issues of energy policy. Those are the main three like negative NCs that would be sort of abstractly justified. Another argument is that there's probably a pretty good argument that says you are better off if you're looking for like utilitarian or consequentialist impacts that like affect the world around us style impacts if you defend a form of rule utilitarianism rather than if you defend a form of act utilitarianism. Just because it seems unlikely that any but a couple of countries like China and the US are single-handedly going to make much of a difference as regards global warming, right? Like most countries that could have nuclear power probably will not individually make any difference to global warming, but it may be that their collective effort is necessary to resolve global warming. And so since a lot of these impacts, like global warming, seem to be tragedy of the commons, which require lots of people to cooperate, even if each person individually does not have a lot of reason to cooperate, it'll tend towards rule utilitarian literature. If you're not familiar with what that concept is, you should talk to your lab leaders. They'll be able to explain it, or you can come talk to me later. A couple other things you should be familiar with. There are going to be questions about impact framing on this resolution, which get tricky when we deal with issues of future generations. And there's lots of philosophical literature that deals with the problem of future generations and how we should understand impacts to future generations and what they mean. The first issue here is what's known as the non-identity problem. And the non-identity problem just says it seems really hard to understand what it would mean to wrong someone who's going to like live in 1,000 years. And the reason is because we generally think that what it means to wrong someone is to make them worse off, right? To like make your life go worse. But it doesn't seem as though it's possible to make someone fall into the future's life go worse, right? Because if we do not make this sort of policy, chances are that person will never exist, okay? That person wouldn't, right? So if we adopt these sort of energy policies, that'll probably mean that the set of people who exist 1,000 years from now are a completely different set of people than would exist if we did not adopt this policy, right? And the reason is because even microscopic changes, right, are going to change the conditions which result in people meeting, people getting married, when they have kids, etc. And tiny changes of when people have kids are going to result in just different kids being born. And so the question is, can you really wrong someone, right, if what you do is also the only reason they exist at all, right? So if people exist and will suffer under, let's say, future radiation, it's not clear that they can be morally wronged by that, because if they were not suffering under nuclear radiation, because we never put this radiation there through nuclear power, they probably never would have existed at all. And if they never existed at all, right, then it's not even clear what it would mean to have wronged them. And so questions of the non-identity problem are going to be relevant on the negative. And if you define a philosophical act, you probably want to take a certain approach to it. There's an author, Elizabeth Harman, who has an article on the non-identity problem, and that actually talks about the context of like nuclear energy, right? And talks about nuclear energy as a specific instance of it. And so that'd be a good place to look for introductions to that idea. The other question is the question of discounting impacts. So it does seem, for instance, in our own lives that we tend to prioritize short-term impacts over long-term impacts, right? Like, if I can put off something I don't want to do, I often will. And there's a question about if this can ever be rational. And there are reasons, perhaps, to think that because we like have special obligations to our children, right, which are stronger than obligations we have to humanity generally, it may be that we have special obligations to like our immediate descendants, right, than we do to people who are going to live like 10,000 years from now, right? Because we have a greater moral distance from them and therefore have less moral concern for them. And if that is the case, these sort of long-term impact questions are going to affect how you frame the moral importance of various impacts as regards our special moral obligation to certain people. So that concludes our sort of summary of some of the major arguments you're going to come across in the literature. We can now answer questions that you guys might have to help clarify or to discuss ideas that you've come across in the literature that you feel like, hey, why didn't you mention this idea? Because it's a better one than what you had. Yeah.
Have you guys looked into these like nuclear Orientalism arguments that like our need to get rid of like nuclear energy is based on unfounded assumptions of like ground bodies in the Middle East?
I didn't focus there was a lot more literature in terms of like instances of Japan, but I'm definitely sure that exists, especially in the ways in which we go about discussions of nuclear energy. So that's something that you should look into, but we did not include that in this because we did not get to that point. Yeah.
Certainly if the app is about terrorism, especially, right, and the dangers of nuclear terrorism, that's going to be a very strong argument.
Mm-hmm.
Iran as well.
Yeah.
Iran.
I think we mentioned very briefly Iran's nuclear power program. I imagine if the affirmative is Iran really needs to give up its nuclear power program because we can't trust them unless they'll get a nuclear weapon otherwise, then that argument might be a strong negative case to that specific affirmative claim.
Mm-hmm.
Yeah. Behind you.
Economically, what are the dangers of just completely eliminating an entire sector of like business? And like it's like the from what I know about economics with bubbles and everything, if everyone's investing so much capital in nuclear energy, and then we say, okay, nuclear energy isn't allowed anymore, that's not just a bubble burst, then that's
So I think realistically, the affirmative should not be claiming that just because the law or whatever bill or whatever this looks like is passed immediately, that it gets implemented immediately. Tomorrow we just shut down all nuclear power plants, and we're like, yeah, sorry, 10% of the country, your power is not going to be on for a few years until we figure out what to do about it. Look, for example, at Germany. Germany decided that it wanted to drastically roll back what it was currently doing with nuclear power right after the Fukushima disaster in Japan in 2011. And what it did was it phased out very quickly some of the older reactors and is looking at a more long-term drawdown from nuclear energy. And so that's probably what it would look like in terms of if we were to commit, any given country were to commit to not producing or to prohibiting nuclear weapons, or not nuclear weapons, nuclear power, then it wouldn't be immediate shutdown of everything. And as the affirmative, you should never walk into a cross-examination question where they say, hey, what would they have happen? Immediately. Because then you'll have a very hard thing to defend, like what you're describing. And so I think that's the natural answer is there's more gradual ways of phasing it out that would overcome that problem. And also bear in mind that many, if not most countries, don't have large nuclear power sectors. And so for the majority of countries, it wouldn't be shutting off the lights immediately. It would just be never starting up nuclear power to begin with.
Finally, it's worth noting people are not investing in nuclear power right now because it's not profitable, right? Like, there are much more profitable ways to produce energy right now, so there's very little market activity as regards investment. Like, the US has not even tried, really, to open up a new nuclear reactor in 40 years, right? And that is pretty indicative of what's lots of countries, the situation they're in. just because it's not a profitable way for individual businesses. So the nuclear reactors that are being set up are basically exclusively being set up by governments right now as opposed to individuals, which is also going to mitigate some of the sort of bubble-style economic impacts you might be concerned about. Fred, did you have a...
Oh, yeah. Sorry. Totally forgot. So when you were doing research on like this gynocentric negative position, did you also find like evidence that basically indicated like thaliocentric representations to nuclear power?
Oh yeah, there's
Tons?
yeah, but a lot of that research is in the context of nuclear weapons. So the reason I didn't go for like you can criticize phallic symbols of nuclear power is because the literature is more in terms of war, but that was specifically talking about nuclear power because it also talks about how it has the potential to nurture, but it also has the potential to destruct. So that's why it was very specific, but there's definitely a lot of stuff in terms of phallic symbols and nuclear discussions in general. You would just have to search harder for it to be specific to the resolution. Yeah. Okay.
Other questions or comments or things you want? Yeah.
Could you explain how like the ruling token because I can see how you can do like AccuTil, but I don't really get the ruling.
Well, so it seems as though act utilitarian ethical theories often run into what's known as a sort of tragedy of the commons, right? Which is a situation where it's in each individual person's interest to not follow some sort of rule, even if the result of everyone not following that rule is going to be worse, right? And that seems, for instance, to often be the case when it comes to issues of sustainability, right? So if we want a sustainable planet, right, it is probably the case that we cannot all eat meat, or at least not eat meat like we currently do in the Western world. But it's probably also the case no individual person's meat consumption is likely to make any difference to global sustainability. Does this make sense? So if I'm just an act utilitarian and say I should just do what maximizes good consequences, it may be that my eating meat will have, right, for like human welfare, a greater positive benefit on my happiness than it will on the sort of general sustainability impacts that one person's meat consumption will make, right? Does that make sense? But from a rule standpoint about what everyone should do, it's probably the case that no one in the Western world should eat meat the way we currently do, right? And so if you take a more rule-based standpoint, that tragedy of the commons can be resolved and say that we should concern ourselves with the sort of sustainability issue. So similarly, since the vast majority of countries will not make a difference to global warming if they act alone, it seems like the vast majority of countries don't have any reason to switch over to nuclear power if that's going to have some sort of negative effects, right, on their citizens, unless everyone else is going to do so too. And so it would seem to imply that a rule utilitarian style negative reasoning might help resolve some of those tragedy of the common issues. All right.
Next is meeting your mentor, which is outside Hudrick Summit, which is the dorm building.
Thank you. That was awesome. Horrible topic.
Yeah, but that was good.
That's good.